and this proton is going to be surrounded by one electron. So am I positive, negative, or neutral? I have one positive, one negative. Am I positive, negative, or neutral? I am neutral. Am I chemically stable? Or do I need to form chemical bonds? What do you think? Do I have a saturated valence shell on here? No. So I need another electron. I need to form a chemical bond to saturate my outermost energy level. How about the carbon? Carbon has 6 protons and 6 electrons. So it's going to have 2, and then the outermost energy level, we're going to have 4 electrons. So how many electrons do I still need to become chemically stable? I need 4 more electrons. So this carbon will make a deal with the hydrogen. You need 1 electron. I will give you one of mine, but you also give me yours to rotate around my nucleus for us both to become chemically stable. So now this hydrogen is chemically stable. About this carbon still needs 3 more, so it will find 3 more hydrogens. Each one gonna have 1 electron and 1 proton in the nucleus. So it will make the same deal with 3 more hydrogens. Did anybody gain an electron? Did I lose this electron as carbon? Or did I gain this electron from the hydrogen? No, we are sharing our electrons. Here, I am sharing electrons. So we call the chemical bond that is formed by sharing electrons is my covalent bond. And here I'm sharing just 1 pair of electrons, 1 pair of electrons, 1 pair of electrons, 1 pair of electrons. So we call the type of covalent bond in which I'm sharing 1 pair of electrons, it's a single covalent bond. And for simplification, when we draw this, it's going to be just one line like this. So the carbon is going to be attached to 4 hydrogens, and the attachment is a single covalent bond with each of them. So here I have 4 single covalent bonds between the carbon and the 4 hydrogens. If I'm looking at something like the oxygen, Oxygen will have 8 protons in its nucleus. And it's going to have 8 electrons. So 2 are located in the innermost energy level, and in the outermost energy level, I have 6 electrons. So again, am I negatively charged, positively charged, or neutral as an atom here of oxygen? I am neutral. Am I chemically stable? What do you think? I have in my outermost energy level, I have 6 electrons. Am I chemically stable? No. So how many more electrons do I need in order for me to become chemically stable? I need 2 more electrons. So I've got 6. In order to become chemically stable, the outermost valence shell needs to have 8 electrons. So I need 2 more electrons to become chemically stable. So I will find another oxygen in the same situation as mine. So it has 2 electrons innermost and 6 electrons in the outermost energy level. Still needs 2 electrons to become chemically stable. So what we're gonna do, we're gonna be making a deal. So how about giving you 2 of my electrons to rotate around your nucleus, and you give me 2 of yours to rotate around my nucleus. So we're gonna be sharing those electrons for me and you to become chemically stable. All right, so here I'm sharing 2 pairs of electrons. What do we call the chemical bonds that will be formed by sharing electrons? It's my covalent, exactly, covalent bond. And here, am I sharing a single pair of electrons or 2 pairs of electrons? 2 pairs of electrons. So I'm sharing 2 pairs of electrons. So we're gonna call this is a double covalent bond. And we're gonna be drawing a double covalent bond as 2 lines connecting the 2 oxygens like this. All right, so let's see another type of chemical bonds. Let's see here the nitrogen. The nitrogen has 7 protons and it's gonna have 7 electrons, 2 in the innermost valence shell and 5 electrons in my outermost valence shell. So again, am I chemically stable here as nitrogen? What do you think? If I have just 5 electrons in my outermost valence shell, what do you think? Am I chemically stable? No, in order to become chemically stable, how many more electrons do I need? If I have 5, how many more electrons do I need? I need 3 more electrons. So what we're going to do in here, the nitrogen will find another nitrogen and will make a deal with it. So I will give you 3 of mine to rotate around your nucleus for you to become chemically stable, and you give me 3 of yours to rotate around my nucleus in order for me also to become chemically stable. So we're going to be sharing electrons. And again, what do we call the chemical bond in which I'm sharing electrons? Nobody is losing, nobody is gaining here. So no positive charge or negative charge ions. What do we call the chemical bond in which we're sharing electrons? It's my covalent bond. And here, am I sharing 1 pair, 2 pairs, or 3 pairs of electrons? Sharing 3 pairs of electrons. So this is going to be a triple covalent bond. Triple covalent bond. All right, so looking at another type of chemical bonds, which is the hydrogen bonds. Do you remember how many protons do I have in an oxygen? How many protons do I have in an oxygen? 8 protons. All right, so let me draw an oxygen in here. So I have 8 protons and 8 electrons. So I have 6 electrons in my outermost valence shell as oxygen. So I need how many more electrons to become chemically stable? Can you remind me? I have 6. In order to become saturated, I need 8 in my outermost valence shell. So I need 2 more electrons. So we'll find 2 hydrogens. A hydrogen has a single proton and a single electron like this. 1 proton, 1 electron. So the oxygen will make a deal with this hydrogen. So I will be sharing 1 pair of electrons with this hydrogen and 1 pair of electrons with another hydrogen. So what kind of chemical bonds do I have in here? What is the type of chemical bonds did I create between the oxygen and the hydrogen? What kind of chemical bonds? According to what we studied, we didn't study hydrogen bonds yet. Here, am I gaining or losing electrons? Am I gaining or losing electrons? I'm neither gaining or losing. What am I doing here? I am sharing, and what do we call the bond that gets formed by sharing electrons? It's a covalent bond. Do I share 1 pair or 2 pairs or 3 pairs of electrons in here? I share with this hydrogen 1 pair, with this hydrogen 1 pair. So I share how many pairs? 1 pair, not 2 pairs. You see on here? How many pairs of electrons are you sharing between a hydrogen and the oxygen? And I'm sorry, the carbon here, it was one pair. So actually you are sharing one pair of electrons here between carbon and 4 hydrogens. Here we're looking at the oxygen. So how many pairs of electrons am I sharing between the oxygen and the hydrogen? Just a single pair. And another single pair with another hydrogen. So we're looking here at a relationship between oxygen and the hydrogen, and the oxygen and another hydrogen. So what kind? All right, so again, how many pairs are you sharing here in this example between a carbon, this is a carbon, and this is a hydrogen. A chemical bond is between two atoms. How many pairs of electrons am I sharing here? So what is a pair? A pair means two electrons, right? So how many pairs I am sharing? Only between this carbon and this hydrogen. How many pairs am I sharing? One pair of electrons. So this one is sharing a single electron, this one is sharing a single electron. So both of them are sharing one pair of electrons. So what do we call this? Single covalent bond. How many single covalent bonds do I have in here in this compound? So the carbon has 1, 2, 3, 4 single covalent bonds. All right. So here between the carbon and the hydrogen, how many pairs of electrons am I sharing? Just one pair. So when I ask you about how many pairs am I sharing here, it's just one pair, not 4 pairs. I'm sharing one pair with each hydrogen. So we're looking here at a relationship between two, carbon and hydrogen. How many pairs? One pair of electrons. Is this clear? Is this clear? Somebody was saying he got lost. Is this clear now? All right. So looking at this example on here. Oxygen and hydrogen. How many pairs of electrons am I sharing? One pair. So what kind of bond is this in which you are sharing one pair of electrons? Single covalent bond. How many single covalent bonds do I have in here? This is a different question. This is another question. I have two single covalent bonds. So what I have in here is oxygen attached by single covalent bond to this hydrogen and another single covalent bond to this hydrogen. I cannot say it's a double covalent bond. It's not a double covalent bond. I'm looking here at relationship between two, not between three. So in order for me to say a double covalent bond, I need to be sharing the two pairs of electrons between two atoms. Is there any relationship between this one, this hydrogen and this hydrogen? Are those connected by any means? No. So you cannot say it's a double covalent bond. We can say two single covalent bonds in here. Is this better now? Yes? All right. So we didn't mention anything about the hydrogen bond yet. All right. We didn't mention anything about hydrogen bond yet. So what do I have in here? I have an oxygen with 8 protons, 8 neutrons, and you see on here 8 electrons. And it formed two single covalent bonds with 2 hydrogens. So what am I looking at? I'm looking at water, H2O. So what is the atomic mass of the oxygen? What is the mass number for oxygen? What is the mass number for oxygen? 8 plus 8, it's 16. How about the mass number for the hydrogen? It doesn't have neutrons, it has only 1 proton. It doesn't have neutrons, it has only 1 proton. So what is my atomic mass? Atomic mass is 1. So let me ask you a question here. And I will relate it to the topic in a second. Which one is closer to the Earth? If this is the Earth, and this is the sun on here. And this is the moon. Which one is closer to the Earth, the moon or the sun? Moon, right? So is the Earth rotating around the moon or around the sun? It rotates around the sun, right? Why? Although the moon is closer, why the Earth is rotating around the sun, not the moon? What do you think? Why the Earth is rotating around the sun, not the moon? Exactly. I have a greater attractional force, higher attractional force created by the greater mass of the sun. So as the sun has a much larger mass, it has a much greater attractional force. Higher mass means higher attraction. So looking back at the water here, this is my oxygen. This is my oxygen. I have a mass number of 16. Compared to the hydrogen, it has a mass number of 1. Did anybody gain or lose the electron in here? What do you think? Did the oxygen gain the electrons? No. Does the hydrogen lose the electrons? No. They are sharing the electrons. But because of the greater mass number of the oxygen, where do you think those shared electrons are going to be moving closer to? Are those going to be moving closer towards the oxygen, or would they be moving closer towards the hydrogen? What do you think? Which one going to be pulling those electrons towards it for most of the time? Oxygen. Why oxygen again? Because it has a greater mass. So what will I see on here? I have oxygen attached to 2 hydrogens, like this. I am forming single covalent bonds with those hydrogen. But the oxygen gonna be pulling the electrons towards it for most of the time, although they are sharing, but somebody is getting more benefit of it. It's like when you buy shares or stocks in the market. So for example, you buy an Apple stock or Tesla or whatever stock. So did they gain your money? Did they gain your money? What do you think? If you buy a share in the stock market from Apple, is it like buying a phone from Apple? Is it the same thing? If I'm buying a phone, if I'm saying I pay $1,000 to buy a phone, so those $1,000 are lost from me and gained by them. If I bought the phone, I pay for it $1,000. So this simply means that I have lost the $1,000 and they have gained the $1,000. This is what we call ionic bond. But if I buy a share in the stock market, I'm buying shares, I am sharing, and from the name here, share, I'm sharing my money with them. I own 1 over, I'm not sure how many, of this company having this stock at $1,000. So am I losing? Did I lose my money? No. Did they gain my money? No. We are doing what? We are sharing my money. And I share part of their revenue. All right, they give me part of the revenue. All right, but who gains the most? Both of us are supposed to gain, right? So they will be producing more products, they will do more research, the value of the company is going higher. So they will benefit, and I will benefit from them as well. But who benefits the most? You or Tesla or Apple? So $1,000 is Tesla now. Who benefits the most from your money? The greater mass. So they will benefit much more than you do buying their stock. Although you are sharing, but somebody is gonna be able to benefit more than the other. And here is the same concept here. I am sharing electrons between the hydrogen and oxygen, but who's gonna be attracting those electrons for most of the time is gonna be the oxygen because it has greater mass. So if I'm looking at a water molecule, the oxygen side is going to be more positively charged or more negatively charged. What do you think? If the electrons are going to be directed towards the oxygen for most of the time, would the oxygen side be more negative or more positive? What do you think? Electrons are negatively or positively charged? They are negatively charged. So the oxygen side is going to be more negatively charged compared to the hydrogen side is going to be more positively charged. Did I say that the oxygen became a negatively charged ion? No, I did not say that. The oxygen did not gain the electron. It still shares the electron, but it's going to be attracting those electrons for most of the time, which will make the oxygen side to become more negatively charged. And the hydrogen side is going to become more positively charged. So let's see here another water. Oxygen forming two single covalent bonds with two hydrogens. So again, the hydrogen side is more positive. Oxygen side is more negative. So what do you think gonna happen between a side was more positive and the side was more negative? Would I have attraction or repulsion between those two? What do you think? Would I have attraction or repulsion between those two? Attraction. But it's not that strong like the ones that I have between the ions, like the sodium and chlorine. Remember? It's a very strong bond. Here, because I am more positive and I'm more negative, so I'm not purely negative and purely positive. So this creates an attractional force, but it's definitely going to be weaker than the ones that I have in the ionic bond. What do we call this bond in which we have attraction between the hydrogen and the oxygen from another water molecule is what we call here is my hydrogen bond. So where is the hydrogen bond on here? It's the attraction between those water particles. Again, why do I have this attractional force? Because oxygen is going to be more negatively charged, hydrogen is going to be more positively charged, so they will be attracting one another. So you see on here, oxygen is more negatively charged compared to the hydrogen is going to be more positively charged. The positive charge, the more positively charged side of this water is going to be attracted to the side which is more negatively charged of another water molecule. All right, so if we're looking on here, a tricky question that you usually see. What kind of chemical bond do you have in a water molecule. So let's answer this as question number 3 for today's in-class activity. What chemical bond do you have in a water molecule? Single covalent bond. 2 single covalent bonds, exactly. Yeah, 2 single covalent bonds. Answer another one here. What kind of chemical bond do you have between water molecules? Here we go, hydrogen bonds. Is the difference here between the two questions is clear? Is the difference between the two questions is clear? Between water, hydrogen. Inside the water, between the oxygen and the hydrogen, is a single covalent bond. Right, you see here, this mosquito is standing on water. Why? Because the pressure it applies by the weight is less than the attractional force between the water molecules created by the hydrogen bonds. The interaction between the air and the water surface creates a force that we call the surface tension. Surface tension. And the surface tension here is what holds this mosquito on top of the water. For question number 5 for today, what type of chemical bonds do we find in salt? Salt, like sodium, chlorine. It's an ionic bond. It's an ionic bond, exactly. Chemical reactions occur when chemical bonds are formed, rearranged, or they are broken. They are represented as chemical equations. On one side of the chemical equation, we've got the reactants. And on the other side is we've got the products of the chemical reaction. Very important to notice on here if you're taking the HESI or TEAS exam, you need to make sure that your chemical reaction, the chemical equation, is balanced. So you have the same number of atoms of hydrogen on one side, same as in here, oxygen on the in the side of the reactants is going to be equal to the number of the oxygen in my products. Somebody is asking, so hydrogen bonds exist between molecules that contain hydrogen but not to form molecules. Yes, hydrogen bonds exist in between the molecules that contain hydrogen, but they are not actually forming a molecule. It's an attractional force that got created between those different molecules. It might be water, it might be other structures that contain hydrogen. with the same exact concept. One side of the molecule is going to be more negative, one side is going to be more positive. All right. So chemical reactions here, we've got synthesis reaction in which smaller particles are building up larger compounds, like for example, the amino acids here, they will build up together proteins. Decomposition reaction, I'm breaking down large chemical compounds into smaller one, and we call those kinds of reactions are the catabolic reactions of the metabolism. Those are, example here is the breakdown of the storage form of the glucose inside your liver and skeletal muscle cells, which is the glycogen, into its simple form, which is the glucose. So we've got here decomposition reaction. Exchange reactions, I am breaking down a bond to build up another bond. Like for example, in the very first steps of breaking down the glucose, in order for me to deal with glucose, it needs to be attached to a phosphate group. So what will I do? I will carry an ATP. I will break this bond between the adenosine and the adenosine triphosphate, ATP, adenosine triphosphate. So you see I have adenosine and 3 phosphate groups attached to it. So you're going to be breaking down the bond between those 2 phosphate and the third one, and you're going to be transferring this phosphate to be attached to the glucose. Here we're looking at an exchange reaction. All right, so if somebody misses a question, please ask me at the end of the meeting. Don't ask me while I'm covering new material. All right, so what's going to be determining the rate of the chemical reaction? We have the temperature. If I have an increase in the temperature, this will directly increase the rate of the chemical reaction, will make the chemical reaction to go faster. Also, the particle size, as I decrease the particle size, this will increase the rate of the reaction. So for example, if I am dealing with large compounds, I will need to break them down first in order to carry on my reaction. So it's going to be taking me longer. So the smaller the size of the particle, the faster the rate of reaction will be taking place. Also, the concentration of the reactant. If I have more reactants, the rate of the reaction is going to be higher. In order to carry on the chemical reactions, I will need catalysts. Catalysts, they will increase the rate without chemically changed. Those are like the enzymes. Those are biological catalysts. Like for example, if I'm breaking down a protein into amino acids in the digestion, I will need enzymes that will be increasing the rate of the breakdown without an actual change to the chemical structure of the enzyme. So nothing changes in the enzyme structure, but the chemical reaction takes place at a much faster rate. Classes of compounds, we have inorganic compounds, and this includes the water, salts, and acids and bases. They do not contain carbon. Compared to the organic compounds, those are like the carbohydrates, fats, proteins, and nucleic acids. And what is common in all those compounds is that they contain carbon and they have a large structure. Water is going to be representing 60 to 80% of the volume of the living cells. Most important inorganic compound in living organism because of its properties. It acts to regulate the temperature, and it's going to be acting as a major transport medium in the body. So in order for me to carry on any chemical reaction, the medium where this chemical reaction is going to be taking place is going to be the water. In order for me to transport gases in and out of the cells, I need water, and so on. So the medium where all the chemical reactions in the cells will be taking place is going to be the water. Also, it's going to be surrounding the different organs, like the brain, for example, it's surrounded by fluid. We call this fluid surrounding the brain is my cerebrospinal fluid, or CSF. And this fluid on here, the major component of it is going to be water, and this will be reducing the physical trauma. And in this example, it protects the brain. Salts, those are ionic compounds that will dissociate in water, like, for example, the sodium chlorine. If you remember, sodium is positively charged, chlorine is negatively charged. So it's so hard to break them, but when you add them to water, they will dissolve. Why? Because they contain cations, positively charged ions, and anions, negatively charged ions, that will be attached to the two components here of the water, the hydrogen and the hydroxyl group. So why, when I put salt in water, it gets dissociated and dissolved? Because water is simply a proton donor and a proton acceptor in the same time. So it has a positive side and a negative side. So when you put salt to it, what happens? The sodium is going to be attracted towards the negative part of the water, and the chlorine is going to be attracted to the positive side of the water. So they get dissociated from one another. So by definition, a salt is an ionic compound, like here, like the sodium chlorine as an example, that has a cation, a positively charged ion, other than hydrogen, and an anion that is other than the hydroxyl group. Ions or electrolytes will be responsible in your cells to conduct electrical currents in solution. This is the type of electricity that we're going to be conducting through our cells. Ions will be playing a specialized role in the body functions, like sodium, potassium, calcium, and iron. For example, iron in your red blood cells is a salt that will be carrying the oxygen for it to be transported from the lungs to your cells. Calcium in your bones is going to be responsible to maintain the strength of the bones. Also, it's going to be playing a major role in the electrical conduction in the cardiac muscle cells, creating this electrical regulation of the cardiac muscle cells. Moving on to acids and bases, which are still inorganic compounds. Acids and bases are electrolytes, means they dissociate when you put them in water. An acid is a proton donor. So when it dissociates in water, it's going to be forming a hydrogen ion. A hydrogen ion is a proton, because remember, hydrogen is formed of one proton and one electron, right? So having a hydrogen ion means I have lost this electron. So what is remaining here of the hydrogen is just one proton. So we either gonna say a hydrogen ion or a proton. Those are the same for us. So an acid is a proton donor or a hydrogen ion donor. Compared to a base is a proton acceptor. How am I accepting the proton? By forming a hydroxyl group when I dissociate. So when I dissociate, a hydroxyl group will accept the proton and will form water. So again, what's by definition is an acid? An acid is a proton donor. So when it dissociates, it's going to be forming hydrogen ion. What's a base? Base is a proton acceptor. What I mean by this is that when it dissociates in water, it forms a hydroxyl group, which has the ability to accept the proton to form water. So what is the only thing that contains protons and proton acceptors that we're going to consider as neutral? What do you think? It's a proton donor and it's a proton acceptor at the same time. I'm a proton donor and acceptor in the same time. So look in here, what's an acid? What's an acid? I'm a proton donor. So when I dissociate, I form hydrogen ion. What's a base? Form hydroxyl group. So I want something that is neutral, neither acid or base. Which means what? Means that it has hydrogen or protons equal to the hydroxyl group. What do I have here that contains protons equal to the proton acceptor? Protons and hydroxyl groups equal to one another for it to become neutral. What do you think? You know something that contains proton and proton acceptor and it's going to be neutral? All right, so the question here, I need a neutral substance. In other words, it has hydrogen, ion, and hydroxyl in the same time, equal to one another for it to become neutral. What do we have? Do we have something like this? Yeah, you combine them, and so the only neutral substance that we've got in here that contains those or any of those two, it's going to be water, right? They combine to form water. So is water acidic? Is water basic? What do you think? It's neutral, right? All right, so we want to check the acidity or alkalinity of a substance. What we do? We checked the pH. pH is a scale that we've created by calculating the negative log of the hydrogen in a substance or the protons. We don't have to worry about this. Yeah. We will not be asking you to calculate this. But when we did calculate the pH of water, we find out that the pH of water is 7. So when we say pH is 7, this means what? This means it's neutral. And the only thing that we know that is neutral is going to be water. Having higher pH having a higher pH greater than 7, it's a base, a basic substance or alkalinic substance. Having a pH lower than 7, going down, it's gonna be an acid, acidic substance. So again, pH of 7 is gonna be the pH of water. It's gonna be neutral. Having pH greater than 7, it's a base. Having a pH lower than 7 is going to be an acid. Is this clear? Just for you to remember, to not get confused which one is greater than 7, which one is lower than 7. Do you know a beverage? Yeah, alkaline is the same as basic. Yes, alkaline is base. All right, so did you hear about a soda called 7-Up? Yeah, 7-Up. So actually, when they first introduced this product, it was to reduce the gastric acidity. So a person who has GERD, burning sensation after he eats, he has acids. So they created this product, 7-Up, to equalize the gastric acidity. So it's going to be 7-Up, it's going up, it's a base. Remember, it opposes the acids. All right, so again, greater than 7, is it a base or an acid? Remember, 7-Up. 7-Up is base. Below 7 is going to be an acid. Remember, 7-Up is for treatment of, or it first got introduced as a treatment of gastric acidity. So it's an alkali. It's a base. So we're looking on here at the pH scale. So we've got 7 is neutral. As I go up, the substance is going to be more basic. As I keep going down, substance is going to become more acidic. So you see on here, the blood is 7.4. So it's slightly basic. Blood is slightly basic. As you keep going, you're gonna get exposed to more alkalinic substance. So go egg white, has pH of 8. Bleach, 9.5. Ammonia, 11. The oven cleaner is going to be very strong base. So it's 13, 14. Sodium hydroxide is going to be of a pH of 14. If you go down here, pH less than 7, like milk, coffee, wine. So milk is slightly acidic. Coffee is going to be more acidic than milk. It's going to be of a pH of 5. Wine is going to be of a pH of 2.5 to 3.5. Lemon juice and gastric juice is going to be of a pH of 2. Hydrochloric acid is going to be of a pH of 0. So again, pH is a scale that tells you the degree of acidity and alkalinity. Lemonade is, lemon juice is like a concentrated lemonade. The concentrated lemonade, yes. That's why if a person has like GERD and he drinks lemon juice, it will make it worse. So he will have more burning sensation if he drinks lemon juice. Yeah, your body has the ability to buffer changes. So if you're taking lemon juice, your body has the ability to get rid of the extra acids. So unless a person is ingesting a huge amounts of a substance, like for example, taking lots of antacids, for example, or consuming huge amounts of alcohol, can cause acidosis, which is the accumulation of acids in the blood. But normally, with moderate amounts of intake of those acids or bases, your body can accommodate and maintain the normal blood pH, which is around 7.4. All right, so your lungs gonna help with maintaining normal blood pH. Your kidneys can help with maintaining normal blood pH. Even other chemicals located as part of the plasma of the blood gonna buffer those changes in the blood pH. So I have multiple lines of defense here in order for me to regulate my blood pH. pH change interferes with cell function and will cause major damage to the living tissues. Slight change in pH can be fatal, and pH is going to be regulated by the kidneys, lungs, and the buffers, which are chemicals that are already present in your plasma. All right, so for the next question, so this is question number 6 on here. Somebody was asking earlier about questions 3 and 4. Those are questions 3 and 4 on here. So how many electrons can a second valence shell hold? Remember, all of them gonna hold 8 electrons, except for the first one. First one holds how many? How many electrons? 2. All right, so this completes our discussion for today. I'll be posting a brief video that will be covering the structure of DNA and RNA and the protein synthesis that we've discussed last class, like a video animation to make a bit for the topic to make more sense. Again, by midnight tonight, you should be able to have access to the lecture exam 1. Lab exam 1. And again, lab exam 1 is going to be proctored. So you need to access it through smarter proctoring. Again, lecture exam 1 is not going to be covering chapter 2, it's going to be covering chapters 1, 3, and 4. Proctored lab exam covers the tissues. The sample questions are not your study guide. Your sample questions that you have on Canvas is not a study guide. This is not a study guide. This doesn't have a complete set of information that you need to know for this exam. Those are just sample questions for you to have an idea about how the question is going to be addressed for you on the exam. You need to study all the tissues that we've discussed together in our meetings. You need to be able to identify those tissues, to mention location and function, as well as the different structures on those tissues. So very important to review the tissues this weekend to prepare and try to get the proctored exam done as early as possible for you to not get any issues just the day before the due date or on the due date. If you've got an issue on the due date and you miss the due date because of a technical problem, I might not be able to help you after you miss the due date. Right? So please don't wait until the due date, at least 1 or 2 days before the due date to get the proctored lab exam done. Also, don't forget about your courseware visible body assignment, which covers the tissue, and this is going to be a very good practice for you before you take the proctored lab exam. Also, don't forget that in 1 week from now, we're gonna have the chapters 1, 2, 3, and 4 quizzes due. Any questions? Any questions? Any questions? All right, thank you so much. We'll see you next week. Have a good one. Please write down your first last name in the chatting box before you leave. All right. Thank you so much. We'll see you on Monday. All right. No problem, Stephanie. That's fine. You as well, Theodore. Thank you. Question number 5. Let me check on here. What was it? This is question number 5 on here. The ionic bond. So the question was, what type of chemical bonds do we have in salts? And the answer was ionic bond. Anybody needs any other question from what we've completed today? All right. Thank you so much. Have a wonderful day. Thank you. Take care. Take care.